In September 1940, Alexander Kartveli sat in his cramped office at Republic Aviation's Farmingdale facility staring at a telegram that might as well have asked him to build a time machine. The Army Air Corps wanted a new fighter. Not just any fighter, but the most powerful, highest-flying interceptor ever conceived, and they wanted the prototype airborne by May 1941. Only 8 months away when most aircraft took 3 years to reach a first flight. A Georgian immigrant who had learned aircraft design in France worked alongside Igor Sikorsky and had already designed the P-35 and the P-43 Lancer. Kartveli chain-smoked his way through the night, sketching on every scrap of paper he could find as he tried to interpret a specification sheet that sounded like fantasy, a fighter that could escort bombers to 40,000 feet, outrun anything the Luftwaffe had, carry 8.50 caliber machine guns, and still survive actual combat rather than just look good in brochures. Inline engines like those in Spitfires wouldn't generate enough high-altitude power, but radial engines created massive drag, and nothing about the math worked. With no digital modeling, every calculation was pushed through slide rules and logarithm tables by a team of only 37 engineers working around a single wind tunnel model. By October, Kartveli made the decision that would define everything, choosing the monstrous Pratt Whitney R-2800 WWII 18 cylinders. 2,000 horsepower, heavier than a small automobile, the same engine the Navy intended for the Corsair, which immediately caused political friction. While Republic's president sued tempers in Washington, Kartveli and his engineers pinned new drawings to the walls every Friday, where Kartveli walked the rows with a red grease pencil, demanding weight reductions and marking revisions. The fuselage stretching to house the massive engine and the wings thickening to hold ammunition for 8 Browning M to South with over 3,000 rounds. The resulting airplane began to resemble a bulbous, awkward milk bottle with wings, earning the private nickname the Pregnant Beast. When Army inspectors arrived in December to evaluate the wooden mock-up, Kartveli barely slept for 3 days. After circling it with tape measures and tapping panels, the lead inspector finally muttered, "It's ugly as hell, Kartveli. Build it anyway," which was as close to approval as anyone would get. The real problem wasn't the engine, but getting it to breathe at 40,000 feet, where atmospheric pressure dropped to a third of sea level and any normal engine would gasp like an asthmatic running a marathon. Only a turbo-supercharger, a device most manufacturers considered too heavy, too complex, and too temperamental, could provide the needed power. General Electric had been developing them for years, but turbo-superchargers were notorious for failures, vibrations, red-hot turbine temperatures, and catastrophic bearing explosions. Yet the performance data was undeniable. A turbo-supercharged R-2800 could maintain full power above 30,000 feet. By January 1941, the spatial puzzle became impossible. GE's massive B-2 turbo-supercharger, nearly 3 feet in diameter, needed to fit somewhere in the fuselage with efficient ducting for both intake air and exhaust. Kartveli first tried placing it behind the engine, but the ductwork became a heated maze of energy-robbing bends that threatened to melt the airframe. Then came the breakthrough: mount the turbo-supercharger in the rear fuselage, running ducting beneath the cockpit, creating the P-47's signature belly intake, an enormous oval scoop that made the aircraft look as if someone had bolted a fighter plane onto an industrial ventilation system. But the straight duct preserved airflow and the rear-mounted weight balanced the massive nose. Metalworkers built seamless aluminum ducts wide enough to crawl through, stress-tested for 400 mph airflow and 9G combat loads. One engineer calculated that at maximum power, the system swallowed enough air each minute to fill a small house. Testing required building the front half of a P-47 on a concrete pad and running the R-2800 at full throttle for hours, rattling windows 3 blocks away, but by March the system worked well enough to risk installing on a flying aircraft. Kartveli's design philosophy, revolutionary in 1941, was simple: a dead pilot can't win a war. While other engineers obsessed over speed and agility, he obsessed over survivability, asking in every meeting, What happens when something breaks at 25,000 feet over enemy territory? The fuel system became the proving ground, with 7 fuel tanks distributed between wings, fuselage, and drop tank provisions, each self-sealing, lined with vulcanized rubber that swelled to plug bullet holes, backed by a carbon dioxide pressurization system to prevent vapor ignition. Redundant cross-feed lines ensured fuel could be rerouted even after severe damage. The hydraulics received dual independent systems with separate pumps and reservoirs. If both failed, a hand pump allowed the pilot to crank the landing gear down manually through 200 exhausting strokes. Control cables ran in separated, armored channels, designed so even catastrophic hits wouldn't jam control surfaces but instead leave them trimmed to neutral. For independent electrical buses, with separate generators kept radios and instruments alive even after severe electrical failure. Critics said the complexity introduced more failure points. Kartveli answered, simple designs make cheap coffins. The R-2800 itself, being air-cooled, could lose multiple cylinders and keep running, a fact later proven in combat. On May 6, 1941, test pilot Lowry Brabham took the P-47B aloft for a routine 15-minute hop, but the massive aircraft needed nearly the entire runway to get airborne. Once in the air, initial handling was heavy but controllable. At 30,000 feet, however, the P-47 suddenly shook itself with a violent flutter so severe that Brabham's vision blurred. The stick vibrated like a jackhammer, and the instrument panel became unreadable. He dove until the shaking vanished below 25,000 feet and landed after 70 minutes, reporting a critical, mysterious flutter. Subsequent instrumented flights revealed sympathetic vibration in the aft fuselage due to turbulent airflow caused by canopy shape interacting with fabric-covered elevators. Wind tunnel tests confirmed the design flaw, forcing a complete replacement with all-metal control surfaces, a strengthened rear fuselage, and a revised canopy adding delays and weight, but solving the deadly problem. Wright Field's torture testing then began, subjecting early P-47Bs to 11G wing loads, thousands of landing gear cycles, extreme heat and cold, pressure tests, and live gunfire into the wings. The 8.50 caliber Brownings shook the airframe so violently during simultaneous firing that the gun camera footage became useless. Engineers added dampers and eventually staggered the firing sequence to reduce vibration. At 35,000 feet, cockpit heating proved inadequate, freezing pilots' feet while poisoning them with carbon monoxide fumes from oil-contaminated air. The heating system had to be redesigned with heat exchangers and detectors. Armor plate thickened behind pilots, capable of stopping 20 mm cannon rounds. The canopy evolved into a full bubble, offering 360-degree visibility. Testing also revealed that a powerless P-47 glided like a streamlined anvil, dropping 3,000 feet per minute, giving a pilot only minutes to find a landing spot if the engine failed. By March 1942, the P-47C incorporated over 270 modifications. The aircraft that emerged looked similar to Kartveli's original concept, but had been rebuilt system by system. Its combat debut came on March 6, 1943, when the 56th Fighter Group escorted B-17s to Schweinfurt. In brutal combat over the Rhine, Captain Walter Cook's P-47 took a 20 mm cannon hit that blew a hole in the wing large enough to crawl through, yet he flew home. Robert Johnson's P-47 was riddled with over 200 bullet holes, 2 cylinders destroyed, oil flooding the cockpit, the canopy shattered. Still, the R-2800 dragged him for 100 miles back to England on 14 remaining cylinders. Ground crews counted unbelievable battle damage, whole tail sections shredded, wings nearly severed, yet hydraulic systems kept working, fuel tanks didn't explode, and control cables remained intact. The survival rate told the story, only 1.9% loss per sortie in 1943. Far lower than P-38s or P-39s, the P-47's early combat radius was short, only 230 miles, but improved external tanks soon allowed deep strikes into Germany. As modifications continued, the P-47 became a hybrid fighter-bomber, carrying bombs, rockets, and strafing weapons thanks to hardpoints Kartveli had deliberately included years earlier. Meanwhile, Republic's Farmingdale plant expanded into a 1.3 million square foot Leviathan employing 23,000 workers in non-stop shifts. Raw aluminum entered one end, and 96 hours later a P-47 rolled out under its own power. Each wing required over 8,400 hand-driven rivets inspected by X-ray. One misdriven rivet meant 30 minutes of rework. Engines, pre-tested by Pratt and Whitney, were mated to airframes with surgical precision, and turbo-supercharger installation specialists worked assembly line miracles. Paint booths blasted camouflage onto the aircraft in 22 minutes, and quality control test cells ran engines at full power for hours before release. By March 1944, Republic produced one P-47 every 103 minutes, with costs dropping dramatically. Additional plants in Evansville and Buffalo pushed production to over 1,300 aircraft per month. By war's end, 15,683 P-47s had been built. Analysts later tallied 3,750 enemy aircraft destroyed in air-to-air combat, thousands more on the ground, and staggering destruction to railroads and armored vehicles. Most remarkable was survivability. Of all Thunderbolts produced, only 3,499 were lost to all causes, and pilot survival was far higher than in other fighters. With more than 60% of P-47 pilots shot down over Europe surviving as pose or walking away, the very weight critics mocked had become its salvation. P-47s routinely landed with 400 bullet holes, missing cylinders, shredded wings, or entire control surfaces gone. Kartveli's obsession with redundancy became foundational doctrine for post-war aircraft. Turbo-supercharger lessons accelerated jet engine development. Intake duct research informed modern high-speed aerodynamics. Republic never achieved the glamour of the Mustang or the intrigue of the Lightning, but the P-47 Thunderbolt became the working-class hero of the skies, ugly, heavy, unstoppable. Its pilots lifelong believers in the machine that brought them home against impossible odds. Alexander Kartveli continued designing aircraft into the jet age with the F-84 and F-105, but nothing matched the Thunderbolt's impact, and he lived long enough to see his once radical belief that pilot survival mattered as much as performance become the foundation of modern fighter design.